Hello everybody, I wanted to talk a little bit about our Earth Science lecture, chapter number 2, and sort of drill down into the second part of the chapter when we are talking about the Earth-Sun system. So how the Earth moves around the Sun and the impact that that has on the Earth. So the Earth, the Sun, and the seasons. Why is it hotter at the equator than it is the poles? That's a pretty easy answer, right? The poles are up north. It's colder up north, but why exactly is it colder up north? And when you answer the question as to why it's colder up north, it really is answering the question of how the Earth and the Sun work together in terms of the heating of the Earth. Why do we have the seasons? Why is it a winter in the northern hemisphere and summer in the southern hemisphere? Why is it hotter at the poles? All those answers come from one basic concept, which is the amount of solar energy, which is insolation. So solar energy is incoming solar radiation. That's shortened down to insolation. The amount of insolation reaching the Earth's surface depends on the angle that the sun's rays strike the Earth. So if we look at our diagram, we can see that down at the equator, when the Earth's rays come in and strike the Earth, they are coming in at the equator almost at a 90-degree angle. Not quite, but almost at a 90-degree angle. Nonetheless, the angle is quite high, so it's very, very direct sunlight. Whereas at the very same day, the very same time, those angles coming in above the Arctic Circle, they're coming in at a much smaller angle, maybe 30 degrees or less. And so because of that smaller angle of the rays coming into to the Earth's surface, you actually have a different amount of solar energy striking the Earth. And the reason why is when the rays come in at a very high angle, like down at the equator, those sun rays are only warming a very small part of the Earth, whereas when those rays come in at the same time, the same day, way up north or way down south, they're having to warm a much larger surface of the Earth. It's like taking a flashlight. If I were to shine a flashlight directly down on this page, it would make a circle of light not about that big. But if I took the same flashlight and I shined it down this page at a really low angle, like 30 degrees, that circle of light would be much more diffuse and would be much longer. And that's the same situation that happens with the Earth's surface. The sun strikes the Earth's surface at the equator directly, and so the same amount of solar insolation has to, or is able to, heat a much smaller patch of Earth, and so it provides more energy and warms it more significantly. And the same thing happens at the northern hemisphere and the southern hemisphere, that at the poles, that ray of sun strikes a much larger section of the Earth and has to heat up a greater area, and so there's less energy per unit area. Now there's one other aspect of this. As we look at the atmosphere is a pretty thin layer around the Earth, but let's say it's not a very good drawing, but nonetheless, when this ray of sunlight is coming in at the equator, it is going through a shorter distance of the atmosphere, whereas here it is going through a much longer distance of the atmosphere. The atmosphere is made up of lots of little air molecules. I'm drawing these little red dots. Those are going to be my air molecules. And those air molecules basically scatter away the sunlight. So the deeper layer of the atmosphere that the sun has to travel through, more of the sunlight, more of the solar energy is scattered away, and less of it reaches the Earth's surface. So this idea of the angle at which the sun's rays strike the Earth's surface is very important. It dictates the fact that it's hot at the equator and cooler at the poles, but it also helps to dictate why we have certain seasons. So more heat is delivered by insolation where the sun is directly overhead at the equator, because the sunlight is distributed over a smaller area, and so the total amount of insolation at the equator, the total amount of solar energy received in any given year at the equator, is going to be much greater than it is at the poles. Now, the Earth does not sit straight up and down in space. As we said, collision with a Mars-sized object shortly after the Earth was formed probably helped to create the moon, but it also probably helped to tilt the Earth on its axis. So why is it colder in the winter and warmer in the summer? Seasonal temperature contrasts are due to the amount of insolation that's reaching the Earth. Essentially what we just told you, the amount of sunlight that is reaching the Earth tells us whether it's going to be summer or winter. Whereas greater amounts of sunlight reaching the surface of the Earth, you can have summertime, and less amount of sunlight reaching the surface of the Earth, you're going to have wintertime. Seasonal difference in insolation are due to the tilt of the Earth's axis. So the tilt is currently 23.5 degrees, and we'll learn that that tilt can actually change over time. Well, the Earth is tilted in space as it goes around the sun, but it's always tilted in the same direction. It's tilted in the wintertime. If the sun is here and the Earth is here, it's tilted in the northern hemisphere away, but on the opposite side, in the summertime, it's tilted toward. So that tilt of the Earth is always pointing in the same direction in space. It's always pointing to the same spot. No matter where the Earth is in its circulation around, and its revolution, its journey around the sun, it's always tilted in the same direction. So if this were the northern hemisphere's winter, that's because the Earth is tilted away. The northern hemisphere is tilted away, where the northern hemisphere's summer, the northern hemisphere is actually tilted toward the Earth. And that tilt allows more or less solar energy to arrive at the surface. So when the Earth is tilted toward the sun in the northern hemisphere, that is our summertime. At the same point in time, the southern hemisphere is tilted away, and because the southern hemisphere is tilted away, then they are experiencing their winter. And we can see that on this illustration here on this particular page. So here we have the wintertime. There's a tilt of the Earth right there, and we are tilted away from the sun. And you can see the tilt of that axis right here, and the North Pole is always pointing to the same point in space, and the point in space it happens to be pointing toward is Polaris, or the North Star, which is way up here. But nonetheless, whether it's summertime or wintertime in the northern hemisphere or in the southern hemisphere, it's dependent on whether or not the Earth is tilted away from or tilted toward the sun. So here we have the situation with the northern hemisphere. Here's the northern hemisphere. It's tilted away from the sun, and so we have less of an angle. The sun's rays strike the Earth at a lower angle, whereas in the summertime, those same sun rays are going to strike the Earth at a higher angle, closer to 90 degrees here and closer to, let's say, 45 degrees in the wintertime. Now, you'll notice that in the spring and in the autumn or the fall, the rays of the sun strike the surface of the Earth pretty much at the same angle, no matter where you are in the northern or southern hemisphere. The differences are based on the tilt, the curvature of the Earth in that situation. So in the spring and the summer, the entire hemisphere is receiving the same amount of insolation, and whether it's hot or cold depends on where you are on the globe. But in the winter and in the summer, it's that tilt of the Earth away from the sun or tilt of the Earth toward the sun which causes the difference in the temperatures that the area has. So the sun is directly overhead at different places, whether it's the tropics or the equator, during different seasons. So during different seasons, the sun is directly overhead. So in our winter time, the sun is directly overhead. In our winter time, we find the sun directly overhead down in the southern hemisphere. It's directly overhead over the Tropic of Cancer, whereas in our summertime, the sun is directly overhead of the Tropic of Cancer. Check that. This is the Tropic of Capricorn in the southern hemisphere. This is the Tropic of Cancer in the northern hemisphere. So Tropic of Cancer here, Tropic of Capricorn here. So in our wintertime, the sun is directly overhead much further south, and in our summertime, the sun is directly overhead right on top of us. So during the summer, in the northern hemisphere, the sun is directly overhead of the Tropic of Cancer. That's in the summertime. During the wintertime in the northern hemisphere, the sun is directly overhead at the Tropic of Capricorn down here. So that's the first two bullet points there. This one, during the summer, the sun is directly overhead of the Tropic of Cancer. And the second one, during the winter, the sun is directly overhead over the Tropic of Capricorn. During the spring and fall, the sun is directly overhead at the equator. So it distributes sunlight equally to all parts of the globe. It's directly overhead over the equator. So the tilt of the sun controls how much insolation reaches the Earth's surface, and the tilt of the sun therefore causes the different seasons. So the reason for different seasons is how much solar energy is reaching the Earth. And what controls how much solar energy is reaching the Earth is latitude, where the further north you are, the lower the angle is, and the further south you are toward the equator, the greater the angle. That's one thing that controls the amount of insolation. The second thing that controls the amount of insolation is the actual tilt of the sun. Now, the sun is in slightly different locations throughout this whole process, this whole trip around the sun. We are about 92, 93 million miles away at one point, and then at our closest, about 94, 95 million miles away at our furthest away. So the aphelium, that's a term for any celestial body. Any celestial body has a perihelium and an aphelium. The aphelium is when the distance between the celestial body and what it's orbiting is the greatest. At that point, it's at aphelium. The perihelium is when the distance between the body and what it's orbiting is the closest. So there is an aphelium and a perihelium for the sun and the earth, but there's also an aphelium and a perihelium for the earth and the moon. There's a point at which the moon is closest and a point at which the moon is furthest away. So all celestial bodies have this aphelium and perihelium. So interestingly enough, our aphelium, the point at which we are furthest from the sun, is our summertime. We are furthest from the sun in our summertime. We're actually closest to the sun in our wintertime. So the distance between the sun and the earth is not the reason for the seasons. It is not the reason for the seasons. That distance is not why we have winter or summer. It's a common misconception. The earth is actually closer to the sun in summer and further away in the winter. Now, that difference in distance does have some subtle impacts on the actual season and seasonality, but it is not why we have one season or the other. So the distance is not the reason. The reason why we have summertime or wintertime is because the amount of solar insolation, the amount of incoming solar insolation, or the amount of solar radiation that strikes the earth, that amount is why we have summer or winter. And again, that amount is controlled by the tilt of the earth and the latitude that you are. So, go to the next slide. And why does the daylight change? And the daylight also changes because of the tilt of the earth. The daylight also changes because of the tilt of the earth. Hours of daylight change from summer and winter. In the summertime, the days are longer. In the wintertime, the days are shorter. With latitude, higher latitudes have more daylight than lower latitudes in summer and less in winter. So, go ahead and put our marker back on here. This is going to be our summer season here. This is our summer, right? Because we are tilted. We're going to assume the sun's over here. And put the sun here. There's my sunlight. Sun here. Oops. Check that. Gotta go back. Bear with me. All right. So this is going to be our summer. There's the sun. And the sun is pointing at the northern hemisphere, and the northern hemisphere is tilted toward the sun. So this is going to be our summer here, all right? I'm going to actually write this all out. There you go. That is our summer. And so the period from when the sun comes up here to when the sun goes down on the other side of the earth, that length of time is greater than for the winter time. So at the same time, this is summer in the northern hemisphere and winter in the southern hemisphere. So they're having winter in the southern hemisphere. And it's literally this distance from when the sun comes up. So here you are. If you're in North Africa, the sun comes up here. There's the daylight. The sun comes up here. And you travel this entire distance around the globe, and the sun doesn't go down till on the other side of the globe. And it is longer than when the sun comes up here in South Africa, where they're in winter. The sun comes up here and goes around and sets here. Comes up here in the northern hemisphere, goes down on the other side. And so this line, literally this line, is shorter in the wintertime and longer in the summertime. Okay, so for our northern hemisphere, in the winter, we are having the same situation. In the wintertime, we have a much longer nighttime. Our nighttime is much longer. So here we are. Here's the sun's over here, and this is our wintertime. And so the sun goes down here and all the way around the earth. So it goes down here and all the way around the earth. The sun is down. And we have a very long nighttime, where they have a very long daylight in the southern hemisphere. So that tilt of the earth also changes the length of the days and the nights. And of course, the length of the days and nights also help to control whether it's hot or cold. If you have a very, very long night, it's going to be much colder than if you have a very, very long day where the sun has lots of time to heat the earth. All right, so that's just a little bit of a refresher, a few more details on the Sun-Earth system. We're also going to drill down to the special composition of the Earth as well. And of course, we'll have more for you with Chapter 3.